Hi, welcome to Track D, AI Product Management. This is part 2 of the series. We are looking at AI Product Discovery and AI PRDs today. Many a times we think writing requirements for AI products, AI features is very similar to the regular products, and junior PMs or people new to this area sprinkle AI words around and think we have written a AI PRD. While that's helping a few, many a times it's confusing the others, and hence this session is very important. What we are going to look at is, while specifying a product, that's right, 90% of the time will work in deterministic products. It might not work here because the rest of the 6% of the time that it's going to fail in probabilistic scenarios, the cost, the branding, everything could take a big hit. And we will all do this through an example of feature that is being built on a product called Rezume.Today. It's a resume validation tool, and a team is building a resume evaluator for candidates. So what are we going to look at it? Today we are going to break down the traditional PRT on a probabilistic product. We are going to see how it's not sufficient. Though it provides certain structure, there are a lot of components missing. What happens with traditional PRD is it is written for a deterministic outcome, whereas AI products are built on probabilistic outcomes. So here, when we give an input, we know what the output will be. The same input you give, the same output will come. But here with AI products, we don't know for sure if the same output will come, because the probability changes every time you send in an input. So while there is a certain awareness of what the output will look like, but it's not 100% the same every time. Yeah, here the behaviors are limited in by design. Only if else conditions of 4 conditions are known, so we know what the outcome or behaviors would be. But here the behaviors become infinite. We don't know how the systems would react, how the users will give input, how the both conversation on the input side and the output side will occur. Here the pass fail acceptance criteria pretty simple, straightforward. QA validates against a particular spec. Here the challenge is that while 94% of the time system will give right answers, 6% of the time it will also give confidently wrong answers. And we as senior product managers need to identify that that 6% might lead to a catastrophic outcomes, failure scenarios, loss of revenue, and so on. We need to plan for that, and this session is all about that. The one sentence that we can put it on our walls is that a great AI PRD doesn't specify what the system will do. Yeah, it specifies what happens when it goes wrong. We are targeting this 6%. Yeah, and how we will know very often that good is good enough to ship. Yeah, that's fine thin line is what we need to identify. Yeah, junior PMs will always write traditional PRDs with AI sprinkled in, but principal product managers need to plan for that uncertainty, discovery of evidence, the quality bar that we need to set, failure design, and also evaluate the product in the right way. Yeah, that all we need to plan as senior product managers or principal product managers. And this is what we are going to cover today. There are 4 parts to this session, and then there is a worked out example in the end. We'll start with discover. We'll understand how PMs earn the right to write the PRD. We'll understand what needs to be part of that PRD. We will defend that PRD with economics, evaluation, and staged rollout. And they need to package. How do we package the whole 3 items into one? The 11 section AI PRD is what we are going to look at. Then we are going to look at Rezume.Today's example of AI PRD, which is filled end to end, just as an example for us to go through. And what we need to understand is that, hey, you don't have to write what the system will do. Yeah, you need to write how you validated it can work, how good is good enough, what happens when something goes wrong in that whole pipeline built around LLMs, RAG, or agents, how you'll keep measuring this, what costs are incurred, and in what sequence will it ship. And that brings us to the first part, which is discover. How do product managers earn the right to write the PRDs for AI products, AI features? Yeah. What we need to understand, one part that we'll highlight in this section is the feasibility. Yeah, how it needs to be measured, not asked. It's not like a regular feature where you go ask a customer saying that, hey, are you facing this problem? Can we automate it? Can we build the feature in the product? Here we need to understand the problem, simulate the current processes, understand what will work, what will not work, evaluate it even before evaluate it for feasibility even before we go and build it out. There are various techniques to do that. We'll look at that. And how do we test the riskiest assumption first? Yeah, and how cheaply can we do that? Even that's what we are going to look at. So why AI product discovery is different, we understood this. Yeah, the three classic risks that we are understanding about is, hey, is it valuable, usable, viable? This from Marty Kagan we understood this. Yeah, is the product valuable to the customer? Can he use it in a certain way? Is it viable to build? Our economics, viability talks about market economics. Marty Kagan spoke about this. AI adds a fourth that dominates them, and that's the feasibility part. And the whole AI risk sits on this feasibility. Can a model actually do this at the quality the workflow needs, at the scale, on the data that we have? Is the question that we are asking for feasibility. Yes. What we can't do is interview everybody and say that, hey, many of them agreed, so we will go and build this feature. We need to discover this by building a small thing and measuring it. Yeah, a technical spike before or alongside customer discovery. It's a small spike, but nevertheless that needs to be done. Yeah, and this feasibility problem kills way more projects uh, because product managers have gone ahead to build it without understanding the feasibility part of it. In Rezume.Today, candidates say that they want a math score that tells you nothing about whether a model can produce one that tracks real fit. Is it feasible? Yeah, score of 100 that a user gets, and he doesn't know what needs to be understood. So having that feasibility first before you build a line of product is very important. And this should be the first assumption that needs to be validated even before you validate for data value and usability. Feasibility tells you, hey, is this model producing a match on the score? Yeah, so that we can track it for the real fit. It's the P score. We look at what's the P score. The cheapest test would be to do it offline. Yeah, you run 150 labeled pairs of tests through the whole stuff, and you calculate is it feasible to do. Yeah, then you look at the data. Is there enough data for us to label data for us to check the coverage, the PI information, and run this through. Yeah, are there enough real pairs of data with outcome, signal, or exhaust data that we can run this exercise on? Value, candidates act on a percentage. Yeah, we need to understand how much percentage of uh, resume matches that we have given will the interview candidate act on. Yeah, 8 interviews plus clickable mock, that could be our cheapest test that we could run. Usability, the gap list is specific enough to act on. Yeah, so Rezume.Today, when it compares your resume with the job description, it will give you a gap list. So can the candidates use the Rezume.Today's difference to build on top of that? Can they fix the resume now? All that needs to be done. So Wizard of Oz test with 5 candidates would help us solve that problem. So what we are trying to say is, for each, if this is false, will the project die? Yeah, we need to evaluate, and we need to put a confidence score around that. Yeah, we need to test the most likely false and mostly fatal use case first. And typically in AI products, it's feasibility and data. Many a times it becomes feasible but there is no data, many a times there is data but there is no feasibility. So both we need to test, and proving that the model can hit the bar in a week before committing a quarter is the whole point of this exercise. Yeah, AI product discovery. So AI specific validation methods or tests that we can run is, at least I could think of these three, which is one, offline evaluation. You take all the data that you have accumulated so far, like data exhaust that has the good outputs, and you convert it into a quick prompt. You measure the quality before building. Very simple mock exercise. Wizard of Oz, AI front end, but when users input, there is a person sitting behind that screen and manually doing that. Yeah. Prototyping, a prototype behind a simple UI. This is the last option. This is completely offline. Wizard of is a screen with a person in the back. Prototype is a simple mock where a simple UI sits in front of users. All the data goes to the LLM and comes back. So with Rezume.Today example, we can do something similar. We can do 150 recruited rated pairs. A prompt output matches these completely offline. Yeah. In Wizard of Oz, secretly writes the AI report for 10 users. Do they act on that? Yeah. Prototype, a front end is there with the back end going data. It comes back and so on. Will users trust that output? And that brings us to the AI PRD part. So we said, hey, AI PRD is not very similar to the regular PRDs that we write for deterministic outcome products. It's a little different. So what all is there in AI PRD? That's what we are going to look at. And this whole AI PRD is not around the happy path that we write in deterministic outcomes. Hey, we expect everything to happen in this way. We are documenting around uncertainty, the wrong 6%. Yeah. So where does the traditional ARD fail for AI is saying on a deterministic behavior. What happens when the given input produces different distributions of outputs? Yeah, can the acceptance be just pass or fail? It cannot. There needs to be a variation of pass or fail, or the acceptance criteria's rubric or criteria itself needs to be very probabilistic in nature. Here the behaviors are enumerable. When you say enumerable, you can count them on your fingertips, or you can list them down saying there are 10, 20, 100 behavior types. With AI, there is infinite input space, because every text that is typed by the user, every input that is given as a token can lead to a different outcome. Every every graph walkthrough that LLM takes when trying to decide uh, a reasoning path could lead to a totally different outcome. So here, the number of input-output combinations go beyond enumeration. Yeah, that's why the spec categories and bounds needs to be very clearly defined, and it might not be possible in every case also. Here the correctness is very binary. It is true or false. It is pass or fail. Yeah. Here quality is a rate. It's a percentage. Yeah. Wrong looks right most of the time because products fail here silently and confidently. Here spec is a quality bar for us. Yeah. And we always need to budget for errors here. We need to always list down how much percentage of failures are we gonna see, and what will we do with that percentage of failures. Are we gonna fail? Are we gonna communicate? Are we gonna put a human in the loop? Are we gonna revert the product back to a deterministic state? What will happen? And here failures are loud. That's what we said. Here failures are silent and confident. We need to design this path explicitly. Here QA is against a spec. Here evaluation is against a data set, a labeled data set. The PRD needs an evaluation plan, not a test script. Very, very crucial to understand this. We'll look at this in detail in the coming slides. while you specify the happy path and hand wave the rest. Yeah, we should not be doing this when we go towards AI PRDs. The happy path was the easy 90%. Yeah, AI PRDs are products live and die in the rest of that part, which is 10%, where uncertainty and failure is guaranteed. And this brings five sections to traditional PRDs that traditional PRDs don't have. These are the additional five features that we are going to see. Discovery evidence. Ideally, whenever we do validation of assumptions, it's through asking questions, interviews, qualitative surveys, and so on. What happens with PRD is it needs to go beyond that. We need to understand how do we collect the evidence. The evidence is typically through uh, offline evaluations of already collected data that are labeled. So we need to understand the behaviors rather than the asks that the users are asking for. Capability and model approach. Yeah, we need to build a capability map, a model family branch, and with the reasoning on why a particular capability needs to go to a particular model, that needs to be reasoned out. Quality bar. How high will we set those thresholds and the metrics that will help us make that will help us achieve the acceptance criteria. Yeah. Failure specification. Every time the system succeeds in deterministic case, we have documented it. In AIPRD, when we know what's going to go wrong, we need to document that as well. Yeah, we need to design the behavior for that wrong 6% as well. And this is the heart of this AIPRDs. And evaluation plan. Remember this evaluation plan is also costly, just like building the product, because you're running the tests again and again for every small change. So every small prompt change, every small input change, we are running all the evaluations, and all evaluations mean there are so many LLM calls being made. So the budget also needs to be there. So we need to measure the quality before and continuously after launch, because there could be model drift, there could be input drift, there could be change in behaviors of the RAG applications, there could be change in behavior of the agents. Everything has gotten probabilistic in the whole cycle, or the ladder, or the whole workflow. So how do we ensure that evaluation or the regression of the product stays consistent even after launch? Very important. For Rezume.Today, evidence collection could be offline evals, correlation plus Wizard of Oz test. The approach that we would typically take is we need to understand the problem statement, extract the required data, do a semantic match between the resumes and your job description, give the LLM the required data, and it gives an output score. Based on the score, we'll generate the gaps. Hey, here is the gap. It could be hybrid, no fine tuning yet. We are not fine tuning yet. Fine tuning as in fine tuning the model. Okay. Quality bar is correlation plus calibration. Yeah. Failure spec is on the wrong score. Hey, how do we uh, uh, ensure the wrong score is limited in evaluations. So evals on labeled pairs and refresh data frequently. Yeah. Probabilistic acceptance criteria and the quality bar, we just spoke about this. Yeah, the system categorizes correctly is not a requirement in AIPRD. What we need to go is go deeper and say what percentages on what set of data and what will be the outcome. Yeah, 90% accuracy, greater than or equal to 90% accuracy on the held out 1000 ticket set. This is the data set. No category falls below 80% recall, and it's measured pre-launch, and weekly we will track the same metric after launch. So that's a good acceptance criteria. This is indirectly an eval. Yeah, this is how we are going to evaluate the product. A number, a data set, and a floor. Yeah, it always needs to have a threshold like greater than or equal to 90%, 80% recall. Yeah, the specific data, what is the data set on which we have specified this, and per slice force. So here it's 90% accuracy on the held out data set, and the whole specific category doesn't fall below 80%. So per slice, there is a floor set. So an aggregate doesn't hide a broken subgroup. So we need to break these into individual categories and then for each of them have a threshold. Yeah, the bar is the workflow's tolerance, not the model ceiling. Model, forget the model for a second. What would be the workflow's tolerance? Yeah, a copilot ships at 70%. That's okay. That's good because there is a human in between to approve the code, um, write the draft and everything. But if it is an auto send, it needs 99% accuracy because if it is auto sending emails, auto committing code, we cannot say 70% is good because then every 3 out of 10 times it's going wrong, which is very high in failure rate. Yeah, deciding the bar is a product decision. We as product managers need to decide this leading, lagging, and guardrails. So these are metrics and the guardrails that we need to build. Always it needs to be there. Yeah, the failure specification and designing for the 6%. So whenever we know that hey 6% of the time it is going to go wrong, how costly is this 6%? How catastrophic is this 6%? We need to understand. So first you need to detect that. So you need to have the required telemetrics, monitoring, dashboarding, everything. Yeah, how does anyone notice even that hey, it's a wrong output? Yeah, you need to do it by confidence score, by review, by downstream checks, by reports, eval monitoring. Any of these processes could do it. Okay, containment. How bad can one thing go? Can the wrong output get? Imagine you're asking a very complex task to be executed by an agent or a LLM, and there are a sequence of steps that it takes, and the first step itself is wrong. It goes in a tangential direction instead of the path that you are expecting it would go. Everything is going to go wrong from there onwards. So you need to understand what's the blast radius. Hey, how big will the problem be? Can it be reversed? How high are the stakes here? How high is the risk here? So that's containment zone for us. Then we look at recoverability. Hey, something has gone wrong, okay, but now can I revert the system? Can I edit it or update it quickly? Can I undo it? Can I escalate it to a human? Can I fall back on a deterministic system where it's more um, controlled and recovery happens for all the users or incoming users since we have seen an error? Yeah, many a times it's always good to have a path B where the path is deterministic in nature, which quickly reduces the blast radius for you until you fix and resolve the issue. Again, depends on the use case. It's not 100% every time solution. Communication. How do we communicate what has fallen to the users? How do we signal this to the users, to the stakeholders? Yeah, we need to show a confidence score, maybe say please review. We need to give citations. Like every time you open Claude, there is a message at the bottom saying that Claude is an LLM which could make mistakes. Please review the responses carefully. Yeah. So, and we need to always budget for this error. That's error budget. Here 6% is error budget. Yeah, instead of pretending errors won't happen, we need to budget them. We'll accept hey x% wrong because a human reviews everyone. In this case we were looking at how which is the previous case, we were looking at how Copilot ships 70%. Here 70% could be okay because there is a human in loop, and here's the detection and recovery for that x%. Yeah, how do we ask that human to detect and recover for that x%? An AI PRD without a failure spec, only the part that was never the risk. Spec without a failure spec, specs only the part that was never the risk. So what we are trying to say here is always have a section where we are clearly saying this is our error budget. And that brings us to the third section of this session. How do you defend it? The PRD that you have written, how do you defend it against a skeptical engineer and a skeptical VP or director sitting in the same meeting? Three things that will get us through: one, economics, evaluation, and the rollout strategy. On the economics, first we need to very clearly write down what will the costs be, or unit economics be, that we will be incurring as part of building this product, because there will be a lot of token consumption, and with the number of requests or queries per second that we are gonna hit, it the budget or the bill will gradually increase. And finally we need to multiply it with the price to get the annual budget. Without writing a growth rate and a budget, at least on a quarterly basis or a half yearly or yearly basis, I don't think we should be shipping PRDs anymore. Evaluation economics. Can we afford to know uh, if it's working? Yeah, we need to name the method. Hey, is it automated? Is it exhaust? Label the data set. Is it judges or human in the loop? And we need to multiply that cost into the frequency, because every time we run evals, there is a cost incurred. Yeah, and that eval outruns value. Okay, it is a narrow scope that we are trading on, and we need to always narrow down the scope if there is so much evals being run, because then the cost is high. Finally, the rollout on the maturity curve. Hey, not launched but staged with gates is what we are saying. Hey, we'll do first a co-pilot, then we'll measure the success, then we'll introduce human in the loop, the automation for the safe slice, and then we'll widen it until a stage where everything is automated fully 100%. Yeah, each stage is a shippable product and a risk gate. So what we are saying is, hey, start with automating only 20% or 40%, measure the outcomes, then automate 40%, then automate 80%, then go 100%. Don't do 100% on the same day, because we need to understand the latencies, the cost, the user experience, and all of this is only gonna come if you do uh, uh, some part of the automation at a time. This doesn't mean you do it in months. This could be done in weeks or days also. Yeah, based on the number of users that you have and the interaction or adoption of the feature with the users. So with Rezume.Today, the unit economics will look something like this. You have embeddings where the resume goes, one rubric call that we need to make. So it will be a few cents at 50,000 requests per day. It's a real line that we are talking about. So we need to cache the job description parsers. Um, Evals, we need to look at recruiter labeled pairs are the cost. So we need to ensure that we budget this per quarter and lean on outcome exhaust, that is labeled a data set. We roll this out with advisory co-pilot first. We prove that the percentage predicts outcomes for 4 weeks, and then rewrite it. Yeah, improve it. We never claim that hey, you'll get the job. We do it in parts. This brings us to packaging the whole AI PRD template, and this is a pretty simple 11 sections that you need to fill. And throughout the next 14 weeks, because this is the 14th week if you are going in the reverse, remaining 14 weeks we'll be looking at this structures. So we start with the problem and the user, then we collect the evidence and tell that hey, we have done the required discovery through the evidence collection. We looked at the three styles of evidence collection. We need to list down the goals and non-goals. What's the scope? What's the not in scope? We need to measure the capability and the approach that we are taking. List down the quality bar and acceptance thresholds. We need to mention how will we manage the failures. Yeah, what's how are we going to manage the failures? We looked at that as well. We need to ensure that success metrics are listed down. There is a certain evaluation plan. We also need to list down the unit economics, because like earlier where we were using CPUs, now we need to use GPUs. So LLMs, the RAG, the vector database costs, everything grows exponentially with the number of queries. Yeah, so we need to plan this accordingly. The rollout and maturity gates, how will we plan for that? The risk mitigation, along with the risks and any open questions. Yeah, Number 2 and number 6 carry the heaviest weight. The discovery evidence and your failure specification. Both are the most important sections. Without this, I would say even the highlighted five, the one in the dark, are more important than the others. But without these two, I think it's a great gating criteria for AI PRD to be moving into the engineering hands or designers. So we need to dwell on these 2 points. Yeah, one, no evidence, it's a wish. Yeah, the failure spec is the heart. How how gracefully can we handle the failure scenarios? This used to happen earlier also in deterministic products, but with the engineering team improving it, the failure scenarios reduced, and it was always handled very gracefully. A PRD strong on 1, 3, and 4, 1, 3, and 4, and weak on 2, 5, and 6 is a traditional PRD in a costume. That's what we exactly want to prevent. Here is the worked out example of Rezume.Today, which is trying to build a resume evaluator against a given job description. So here the problem statement is something like this. The candidates can't tell how well their resume aligns with the job description before applying. So there is no clear match percentage, there is no specific skill or experience or keyword gaps listed. So candidates, their interview rates stay low, and tailoring is scattershot. Scattershot as in they improve one or two sections, forget the others. So, as an active job seeker who's trying to apply to a specific role, and he's trying to search anywhere between 10 to 50 applications per search. So, it's volume driven, he has to do a lot. And the goal is that, hey, there is a honest, explained fit before applying. I get a actionable JD grounded gaps identified on my resume that I can then improve to uplift my interview rate, because resume qualification determines your interview rate. So I need to uplift that rate. So that's the goal that we are trying to measure. Non goals, we are not doing any of this. No auto applying, not an employer side screening, no ranking tool, no outcome guarantee, no ATS integration, none of these. Yeah, all these are scoped out. Discovery evidence, how do we collect the discovery evidence? We are saying we are only will do a feasibility test through offline evaluations. We'll do a prompt only prototype on 150 recruiter rated pairs. So we'll go to recruiters, we'll collect the resumes and the job descriptions which were successfully accepted, and the ones that were rejected. We'll also capture the details on why they were rejected, what did the evaluation gap look like. And then we will run the Spearman test for the P score. P score should be 0.62, which is a high correlation, saying that 62% of the time the system agrees with what recruiters are agreeing with. Yeah, and gap precision should be 84%. When the gaps are listed, it also should list 84% of the gaps listed. Yeah, that's green enough to build. Yeah, feasibility weak spot, if the scores are less than any of this, we will not go ahead. This should be a dead end. Data wise, we need at least 4,000 historical pairs with an apply interview outcome signal. While these are positive ones, we need at least 4,000 ones. And that will help us build that PI information also on the resumes. That's PI for us for this exercise. Okay. The value or usability, wizard of odd test, which is the 8.7 out of 8 edited after seeing gaps. The percentage alone was ignored unless the y was shown. Yeah, that's what we are trying to measure as an evidence here. Feasibility will yellow green. Data adequacy will tell us, hey, are we covering the required risks? The value usability is strong and the gaps are explained. Yeah, that's enough evidence for us to justify the build. This evidence collection says that can we go forward. And on the capability approach, this is how we will solve the problem. This is the approach that we are taking. Ultimately, what we are doing is calculating a match percentage. So how is explained here in the capability. We need to do understanding, extraction, match of JD and the resume to get a semantic understanding. We need to put that understanding into a into a score, which is like a rubric, which is very much calibrated, and we need to generate the gaps. So this is the whole workflow. There is no act, there is no agent in between. It's all pure human to begin with, and we can include a LLM plus embeddings pipeline. So there is no autonomous actions being taken. It's purely an LLM plus embeddings pipeline call. So we get two things, JD and CV. We need to parse them. We need to extract all this data. Once done, we need to calculate the skill coverage. Is it how much is required, how much is nice to have, matched by the embedding cosine distance. Okay, experience fit, how many years of experience does they have versus the minimum experience asked in the ratio. The title or seniority relevance. Keyword ATS for ATS application tracking system match. Hey, is the exact term overlapping? Semantic similarity. Is the cosine distance between the embedded resume data and the embedded JD giving a semantic score. And this is the match percentage. We will do calibration of 0.45 into skill, 0.2 into experience, 0.15 into keywords, and 0.2 into semantic, totally giving us the 100% score. Gaps that we want to identify is, hey, we will use LLM as a judge, and this will be grounded in the job description. Yeah, and then it will give us a list of gaps that we need to identify. Guardrail that we should put around is here is never invent skills. If there is not in JD and not in resume, do not invent new skills. Yeah. So, and what will be the quality bar? We need to ensure that the score correlation that we are talking about has a gating of 0.65. Personalized score is 0.55 for each role family. Yeah. The calibration that we are doing is 10%, within 10% of the interview rate. A user should be able to attend an interview rate. That's how we are going to measure this, and it should be within plus or minus of 10% of interview rate. A gap quality, if the accuracy is only greater than or equal to 90% and relevant, then we'll measure the gap quality, and it should be greater than or equal to 90%. That's what we are saying. Hallucinated gaps should be less than 2%. No gaps should be identified that are not part of the job description. Latency should be P95 should be less than 5 seconds. We are not talking about averages, we are talking about percentiles. We also look at failure specs. We are saying, hey, while you detect the gaps, it's through calibration plus OD flags, um, uh, um, and reports. What is OD flags here? I'll come back to this, guys. Yeah, I'll put it in the comments. Containment. We are not looking for advisory, and we never gate an application. We only give the required output. Recovery. Show the Y flag. Flag a bad gap. Reanalyze. Communication. Bad plus guidance. Hey, we need to cite the job description lines. We are telling you there is a gap because it is in job description. That needs to be very clear. Errored budget. Yeah, plus or minus few points. Greater budget blocks rolled out. The bar is set by the workflow, advisory and human in control. So it's tolerant. There is no autonomous job application happening. So it is tolerant in nature. And we are not auto gating anyone's application from applying. So this is good, but by design. The containment advisory only is what makes a wrong score safe here. Yeah, we are safe to a certain extent. Metrics, economics, rollout, and risks that we are going to look at. Gap action rate. This is a leading indicator. With us identifying a certain gaps, is the user improving his resume or not? That should be greater than or equal to 55%. Interview rate uplift. All the suggestions that we recommended, and if it matches greater than certain percentage, which is in this case 90%, we are saying relatively 15% higher uplift will happen. That is in the interview rate. The calibration error on the guard, we are saying less than or equal to 10%. The hallucinated gaps again on the guardrails. When I say guard, it's guardrails. It should be less than or equal to 2%. Name or school score gap should be less than or equal to 2%. Yeah. Economics, we already calculated. If it is 2 cents per analysis, number of 50k requests into 365, how much will it come for a year? Yeah. Rollout, we'll do an internet evaluation, we'll do advisory beta, then we will rewrite it manually and then do a JD tailored, each with a gated metric. Top risk is PI information, hiring adjacent bias. If there are skills adjacent to what we have already listed in the job description, can there be a bias on that? We need to be very careful that advisory framing lowers the exposure. Run the name or school bias test for every release. Yeah, that we need to do. Does closing the surfaced gaps actually move the interview rate or only the score? Does closing the surfaced gaps actually move the interview rate or only the score? So is the user taking an action to improve it? That's what we need to understand. So maybe the product can build another feature to track incremented percentage, then user can come back and give a feedback saying that yeah, by improving this resume I got an interview, and that interview success rate we can track. Yeah, the stage one advisory beta is designed to answer exactly that, yeah, before investing in rewrites and tailoring features. So if yes, if users are looking at the gaps, improving it, and coming back and giving a feedback that yes, I was successful by covering these gaps, then we can go ahead and build the other features like rewriting it and tailoring it to the JD. We specify the uncertainty also at each of these levels. If you remember this from our first week, we spoke about feature altitude, product altitude, and business altitude. At a business altitude, which is 10,000 feet or 20,000 feet, we need to understand, hey, what's the running cost? What is the value of affordability? And the staged maturity curve that will live in the document. This needs to live in the document, okay? So it survives both the engineering and the executive review. We just saw that, okay? Offline eval answers the feasibility question, users can't, and it's for pennies. So that's the product altitude that we need to build. And this is very much the reason that a quarter could go waste, because we have not evaluated it in the correct way. Also, the assumptions first that we need to take and evaluate for the riskiest first. Feature altitude is pretty simple. We learned this. We need to not build for the happy path, but for the 6%, and that's a PM's job. Yeah, we are not writing what the system will do. We are saying how we validated it will work, how good is good enough, and what will happen when something goes wrong. Yeah, how will we keep measuring what it costs, and in what sequence will it ship to the customer? This brings us to the interview prep, and these are some of the questions that we think will be asked in the interviews. You're saying if an interview asks how is AI discovery different, we need to understand that with AI there are certain unique risks that come up with, and you can't ask these to the customers. So we need to evaluate these on offline real data before you can actually give it as a requirement to the engineering team. Also, we need to rank the assumptions most fatal first, and we understood that feasibility and data come on top before your usability and viability come. Yeah, we need to write an acceptance criterion for a classifier. Yeah, so we understood three things: one, a threshold or a number, the specific data set, and not just the whole feature, but if there are sub features within that, we need to slice them and set bars for each of them. And that's where this formula comes: a number, a threshold, um, the specific data set on which we are classifying, and a personalized score. Yeah, we need to set the bar so that the workflow tolerates. Yeah, and we don't design it for the model ceiling. Yeah, this for the whole workflow. What's in an AI PRD that isn't a traditional one? We saw this. Discovery evidence is very important, our probabilistic quality bar, but the most two important things we saw was the failure spec, the discovery evidence. We also need to have a strong eval plan, and these things make it different from a traditional one. A model is 94% accurate, ship it. It'll depend. I would say no, but it depends on the workflow tolerance. If it's human in the loop, ship it. Yeah, which is reversible and reviewed, maybe we can ship it. But if it is irreversible like an auto act, then we say no, because there could be loss of revenue, there could be loss of customer experience, and so on. What we need to do is then spec the failure path. We need to very clearly spec the failure path in most in the greatest detail possible, and then ship it. How do you specify what happens when it's wrong? We understood the 5 things that we need to do. First four are important. Fifth one is like a grouping of all. We need to detect, hey, what's happening, where is it happening, and so on. Containment, we looked at the blast radius, how big is the blast. Recovery, what will we do when it goes wrong? Will we edit, fix, undo, put a human in the loop, revert it to a deterministic path? What will we do? Communicate, how will we communicate it to the user, to the stakeholders, to the business, to the support team, everybody? Finally, how will we frame this as an error budget? That 6% going wrong, how will we budget for that? Yeah, all these four items needs to be framed as an error budget. And that's the vocabulary we learned in this session. Yeah, one idea that we started was that AIPRD specifies the uncertainty. Evidence, we have to get it. We have to tell how good is good enough, and what happens when something goes wrong. How will we know? How will we communicate? How will we contain? What's the error budget? Discovery, yeah, we said, hey, feasibility is not measured. No, it's not asked. You need to collect the required evidence. Yeah, you need to list down the assumptions. Riskiest ones needs to be first evaluated. Offline evals is one way of doing it. Wizard of Oz is another way of doing it, and prototype is another way of doing it. You know, all this come on the testing of our offline evaluations on the data set. Yeah, we need to specify how do we write the traditional PRDs is not how we write the AI PRDs. There is a big difference on the both, and the 5 AI sections that you need to keep an eye on that we looked at. Acceptance, we now know that it is a number plus data set plus force. Yeah, and the bar that we need to set tells us what is the workflow tolerance of the system. That's the quality bar that we are setting. We also looked at the failure spec that we need to write, where failure spec contains a detection. How will we monitor it? How will we contain the blast radius? Or what's the blast radius? How will we recover from it? And how will we communicate? So that's needs to be budgeted in our error budget section. And defend and package, we looked at, hey, how every PRD should have a unit economics, because this is a AI PRD. You need to know the growth of the users, growth of the token consumption, and multiplied by your 1k or 1 million token price, you get the total economics. And it needs to be budgeted for every quarter, half year, or year. Yeah. And evaluation economics, you also need to understand every time we change something, we are going to run evals, and evals have their own costs. And how would we do that? Will we do a certain scoped change? Will we do a full run? How will we do that? And we need to do a staged rollout. We will not do 100% automation in the first step. We will do it with minimal, then bring in copilot, then bring in human in the loop, then maybe do 100% automation. And we looked at the 11 section template also. Now you own this vocabulary. Yeah, now you can write an acceptance criteria for a probabilistic system and a real failure specification for the wrong 6%. And I would recommend that you practice this, write your own AI PRD using the sections that we just discussed, and spec the wrong 6% first, not just the happy 94%. Because when you can't spec what an AI will do, your spec happens to be wrong. So fall in love with that problem, and not the solution. So give it a try, and that was Track D Part 2 for you.